This is lab 10.4. So I went ahead and I took some hydrogen peroxide. I measured it out. I ended up with 115.5 grams of hydrogen peroxide in my bottle. I then took my yeast and I put it in the balloon. I dumped it and waited until all of the bubbles popped. And then I proceeded to do the lab. So that took several minutes. We didn't need to film that. It's not very exciting. I grabbed a measuring tape because not only do I chemistry, I home ec. And I measured my balloon. And here we go. It's time to start doing some math. I did all of the work for you. All you guys have to do is follow along and figure out what the lab's about. So this should be in your lab report, all the math, but I did it for you, so it should be the easiest lab you guys have ever done. All right, here we go. Hydrogen peroxide balloon. All right, here we go. Hydrogen peroxide, I had 115.5 grams. My room temperature is 62 degrees. It's kind of cold in here today. 62 degrees Fahrenheit converts to 17 degrees Celsius or 289.82 degrees Kelvin. My vapor pressure, the vapor pressure I found by looking in the back of the book. In the back of the book, there is a chart where you can look at the different room temperatures that you have and you can find out your various vapor pressure rates. So here, if you go, it's clear back, the back cover has the vapor pressure for water chart. So I found my vapor pressure by just referencing how warm my room was, 17 degrees Celsius. So then that gives me a 14.5 torr, which I then converted to atmospheres. So that's 0.0191 atmospheres. Then I looked at the barometric pressure reading for the time of day. I had it accurate to 15 minutes, so that's pretty good. The barometric pressure was 30.27 inches, which I converted to 1.011 atmospheres. Then I took the circumference of my balloon. The circumference of my balloon was 39.2 centimeters on my measuring tape, which is a very accurate way to do this. Then I did a conversion to the radius. The radius of the balloon was 6.24 centimeters. Then I calculated volume. This calculation I went ahead and wrote out for you. So volume, I'm sure you guys are familiar with volumes of spheres, but it's 4/3 times pi r cubed. So I wrote it all out. That gives me a volume of 1,018 centimeters cubed, which is converts to milliliters. Remember, our centimeters and milliliters, they're designed to let you have just direct conversion. So we were very easily able to say, okay, if we have 118 centimeters cubed, we also have 118 milliliters cubed. But we need our units to be into liters. So that's really simple. 1,018 milliliters is 1.018 liters, right? So then we took the pressure of oxygen. We calculated our pressure of oxygen by looking at our atmospheric pressure, right? The 1.011 atmospheric pressure, and then we went ahead and we subtracted our the vapor pressure. So by subtracting the vapor pressure from the barometric pressure, we got the pressure of oxygen. Okay, so we calculated out the pressure of oxygen over here. Then we needed our pressure of oxygen, and this is our calculation for moles. So we needed our pressure of oxygen, and then we have our standard, the variable R in our ideal gas equation. Our variable R is this 8.21 or 0.0821, and then we can cancel out units all over the place. And what we ended up with is we have 0.0424 moles of oxygen. To calculate the moles of H2O2, that it's just the same times 2. And then we went from moles of, how many moles? We have 0.0848 moles of reactant in our reaction. And we know that our molar weight of H2O2 is 43.02 grams. We know that because we just went to our periodic table and added up what their atomic mass is. By adding the atomic mass, we got 34.02 grams, and we multiply 0.0848 moles times 43.02 grams, and we found out that we have 2.88 grams of H2O2 reactant in this lab today. So the question was, what percentage of our hydrogen peroxide, our original 115.5 grams of reactant, what percentage of that reacted in our redox reaction today? And the answer is 2.49%. And I'm sorry, that one was written sloppily. So there you go. I'm going to just show you my board. Here we go. All the things that you need to know to write this lab. All of the math worked out for you. And if you need to reference how I went through any of these processes, you can look at page 322. 322 in your book shows demo math using their readings. I did the exact same math using my readings and our current barometric pressure. And hopefully this will be one of the easiest difficult labs that you've ever done. I will see you guys tomorrow in class. Have a great day.